Imagine holding a simple egg in your hand. Fragile, delicate. One small drop and it shatters. Now imagine this same egg falling from space. Not from a building, not from a plane, but from the edge of Earth itself. Would it explode, burn, freeze, or somehow survive? Today, we're about to find out. Welcome to the Space Insight. Space feels silent, calm, almost peaceful when we look at it from Earth. But the moment an object leaves orbit and starts falling back, everything changes. Gravity takes control, speed increases, temperatures rise, forces become violent, and our tiny egg is about to experience all of it. Let's start where space begins. Roughly 100 kilometers above Earth lies the boundary we call space. Up here, there is almost no air, no sound, and no protection. If our egg is released at this height, it doesn't fall slowly. There is no gentle drop. Gravity pulls it instantly, accelerating it faster and faster toward Earth. At first, nothing dramatic happens. The egg floats for a fraction of a second, suspended between space and Earth. But then gravity wins. The fall begins. As the egg descends, it starts moving at incredible speed. In space, there is almost no air resistance. That means nothing is slowing it down. It keeps accelerating, reaching thousands of kilometers per hour. And this is where the real danger starts. Because Earth is wrapped in an atmosphere, and the atmosphere is not friendly. As the egg hits thicker layers of air, the air molecules begin crashing into it at extreme speed. This collision creates friction, and friction creates heat, enormous heat. This is the same reason meteors burn up in the sky. The egg's shell begins to heat rapidly, not warm, not hot, but burning hot. The outer surface experiences temperatures hotter than lava. The shell starts to crack, blister, and weaken. Inside, the egg white begins to cook instantly. The yolk thickens, then hardens. At this point, the egg is no longer just falling, it's re-entering. Welcome to the Space Insight. Re-entry is one of the most dangerous phases of any space mission. Spacecraft are protected by heat shields designed to withstand thousands of degrees. Our egg has no such protection. It is exposed, completely vulnerable. The shell starts to fracture. Tiny cracks spread across its surface. Air pressure builds inside as gases expand from the intense heat. The egg vibrates violently as turbulence shakes it from all directions, and then comes the breaking point. The shell fails. The egg bursts mid-air long before it reaches the ground. Liquid egg scatters instantly, vaporizing into microscopic particles. There is no splash, no impact, just destruction in the sky. But let's change the scenario. What if the egg is protected? What if we give it a capsule? Imagine the egg placed inside a small heat-resistant shell, similar to a spacecraft. Now things get interesting. As the capsule falls from space, the heat shield absorbs the extreme temperatures. The outside glows bright orange, then white-hot. Plasma forms around it. The capsule screams through the sky faster than sound. Inside, the egg is shaken violently but remains intact for now. As the capsule slows down, parachutes deploy. Speed drops from thousands of kilometers per hour to just a few dozen. The capsule gently descends, and finally, it lands. The capsule opens. The egg is still there, uncracked, unbroken. This tells us something powerful. The problem was never the fall. The problem was energy. Gravity doesn't destroy objects. Sudden energy release does. Speed, heat, pressure, and impact. These are the real enemies. Welcome to the Space Insight. Now let's push the experiment further. What if we drop the egg from orbit? In orbit, objects aren't actually floating. They're falling constantly, but missing the Earth due to forward speed. If we remove that forward speed, the egg doesn't just fall. It plunges. From orbit, the egg reaches hypersonic velocity. That's more than 5 times the speed of sound. At this speed, air behaves like a solid wall. The egg would not survive even a second. It wouldn't just break. It would disintegrate. The shell would atomize. The contents would vaporize. The egg would become part of the atmosphere itself. This is why satellites burn up. This is why space debris doesn't rain down every day. Earth's atmosphere is a shield, brutal but protective. And here's something even more fascinating. If Earth had no atmosphere, the egg would fall silently from space and smash directly into the ground at incredible speed. No fire, no burning. Just a catastrophic impact. The atmosphere both destroys and protects. It burns objects, but it also slows them down. Welcome to the Space Insight. So what did we learn from dropping an egg from space? We learned that survival from space isn't about strength, it's about control, about managing heat, speed, and energy. This is why space travel is so complex. Why returning to Earth is harder than leaving it. And why something as simple as an egg can teach us about the most advanced science humanity knows. Next time you crack an egg in your kitchen, remember this. That fragile shell could never survive space alone. But with the right protection, even the most delicate things can return from the edge of Earth. If you enjoy exploring space through simple ideas and powerful science, you're exactly where you need to be. Welcome to the Space Insight. Space isn't just vast, it's humbling, and it always reminds us how small and how brilliant we truly are.